Hi, this is Chaoyuan, and my topic is predicting the total amount paid by each user within 45 days. So firstly, I want to introduce my dataset. In this dataset, we have a total of 109 features, which includes game data, payment amounts, and in this dataset, we have some game data. Game data includes the number of resources collected, the level of virus buildings, the number of player battles, and online time, and other features. For example, this feature means all the users collected in the game, and we also have some other features like payment amount. The payment amount includes the payment amount within 4 days and 7 days. This one means the payment amount within 4 days of each user, and this one means 45 days they spend in the game. Okay. Next, my project use like the Python, the Jupyter Notebook, and this application Orange. I use these tools to realize my project. So the first section, I import the dataset into the Jupyter Notebook, and we can see the head of this dataset. There are many features here, and this function describes the length and width of this dataset. In the next section, I did some data preprocessing to check if there is some null values or duplicated values in the dataset, and we can see it's a very clean dataset. We do not need to do some preprocess. Yeah. And this function describes this dataset, and we can see some key points like mean value and median value of each feature. So in the next part, I did some feature engineer. The first one is about paid price, and in this section, I try to find a payment point so that users have a greater possibility of paying later. And we can find if the user paid 6 in the first week or in the first 7 days, the percent of their continuous payment is greater than 0.5. So I mark the users who paid more than 6 as high value user, because we need to predict their payment amount within 45 days, and this is a very important feature. Next is about the playtime. Here I extract the playtime of non-paid users, and you can see how I describe the data about playtime. And just like the last section, I found that when the online time is less than 15 minutes, the proportional payment amount within 7 days is 1.3. That's not a high value, so I mark such users as low value users. Next is about the game win rate. In this section, I try to compare the game win rate between paid users and non-paid users, and it also includes PvP game mode and PvE game mode. I didn't find some difference in the PvE game mode, but in the PvP game mode, paid players have a significantly higher win rate than non-paid players. So I mark players with less than 25% win rate as low value players. That's it. And in the next section, I did some prediction. So firstly, I splitted the dataset into trend dataset and test dataset. You can see here. And I also used three models to predict the payment amount within 45 days and try to find the best one. This one is about the linear regression and the random forest and gradient boosting. This is the fit function, and this is the scan of trend dataset or the performance of the model on the trend dataset. And this one is about the test scan. And finally, I use the RMSE to describe the performance of each dataset, each model. Sorry. And actually, we can find that this model, the linear regression model, actually has a better performance, cause the RMSE of this model is comparably lowest. Here. Yeah. This is the part I did within Python, and I also use the orange to try to visualize some data and try to evaluate the model within some other metrics. We can see here the box plot. We can select different features to see the distribution of each features, like the labor distribution here. Yeah, this is the data table. You can see something about each feature like this. This is the distribution, just like the box plots. And actually, I have found out that the linear regression is the best model, so I only use this model in the Orange app here. And we can see some other metrics like MSE, MAE, and R2. The RMSE here is actually similar to my prediction in the Jupyter here, cause I use RMSE here is 56 and RMSE in the Jupyter is 73, cause I use the cross validation in the Orange and I didn't use that in the Jupyter, so you know. And these metrics are also very important and can describe the performance of this model better. And that's all. Thank you.